got? Testing sound. Okay, great. There's an echo. I just gotta fix that. Testing sound again. That's still annoying. Wow, that's a big echo. All right. Let me just see what else I can shut down here. Let's test this. Test this sound. Come on, man, this is annoying. Can you guys hear an echo? I'm using XSplit. Oh, it's weird because it's just me that's actually hearing echo here. Okay. In that case, I'm going to take my mic off and just try and do this without my headphones. Alright guys, so this is the first time I'm actually doing this tutorial. So basically what I generally tend to do is like kind of show that these are the types of questions that I'm going to be working on today's tutorial. The reason I actually picked these questions is because these are the types of questions that I keep repeating itself in the MCAT. So today we're just going to be looking at a couple of exponent questions. There's about 4 of them. And then I've got 2 more questions here, which are some perimeter questions, which I also see popping up. Okay, so I hope you guys got all of that, and we'll get started with the first question. So I've always seen this type of exponent question coming up where they actually have, I'm looking at the first question here. All right, so where they have like 2 to the power of x times 16 equals 4 to the power of x. So one of the things that you guys need to know is that with the MCAT, they always give you guys really easy numbers to work with. So they don't actually throw in like really complicated numbers or anything like that. When I talk about easy numbers, what I mean by is when you're especially working with exponents, I think you work with 2s, 3s, 5s, maybe 10s that you might actually see. In this case, I've actually chosen to work with 2. So the first kind of idea that you need to realize is that, let's get rid of that, is whenever we see exponents, we actually want to replace it with the correct base. So when I'm talking about base, I'm actually talking about the number 2. That's the lowest base in this, because if you think about it, 16 and 4, they're all 2 to the power of something. So we can actually, what I tend to do is like on the side, I usually kind of write down 2 to the power of 1 is 2, 2 squared is 4, 2 cubed is 8, 2 to the power of 4 is 16. And if you forget those things, you can kind of just really do it on the side real quickly to kind of help you guys out. So what I'm going to do is what I want to do is I want to replace 16 and I want to replace 4 with powers of 2. So that's what I'm going to try and do here. So 2 to the power of x, I'm going to leave it as it is. So it's just going to be 2 to the power of x multiplied by 16, which is 2 to the power of 4. But 4 here is actually 2 squared. So I can actually rewrite 4 as 2 squared. All right, and then I'm just going to leave x as it is. So that's one of the things that you kind of need to do. And I think majority of the papers that I've seen, if you rewrite the question with base power 2, you do get an achieved grade for it. So, I mean, it's one of those easy achieved grades to actually pick up. So what our next step is that, remember that we can actually expand, combine the 2 powers, not expand. So when you actually have powers of powers, you just multiply them together. So this would be replaced as 2 to the power of 2 times x. And then on this side, when you have 2 bases that are the same, and if they have powers, you actually add the powers up. So that's going to be 2 to the power of x plus 4. So we can then rewrite this as 2 to the power of x plus 4 equals 2 to the power of 2x. Now I've chosen a really simple one here just to kind of get started. Once we get them to this stage where the base is the same on both sides, we can almost kind of say then that the powers then are equal to each other. So it's kind of like saying like forget about the base and we're just going to look at the powers themselves. So when we do that, we're going to get x plus 4 equals to 2x. So at this point, we need to rearrange for x and actually figure out what it is. So I'm just going to move the x to the other side, which means it's going to become minus x. And then 2x take away x is just x. And I've got 4 on the left-hand side. So the final answer is 4. All right. So that is basically the first kind of exponent that I actually wanted to go through with. If you guys would like another question like that, can I just get like a little yes or something? Because I'm not sure if people are actually hearing what I'm saying. Okay, so that's a yes, I want another question. Like, I'll tell you what, I'm going to throw up another question because I got a couple of yeses here. But this time I'll give you guys a bit of a heads up. I'm making up questions on the spot, so it might not work out, but we're going to try it out anyway. Okay, what I'd like you guys to do is have a go at this question here. And remember, I told you guys that in the MCAT you always end up getting some really easy numbers, and in this case you've got a nice clue here. The clue is the lowest base that you can rewrite all these numbers is in 3. Okay, so what I'm going to do is I'm kind of going to go through it, but you know, if you are listening, just kind of mute maybe and look at my answer. But basically what I'm going to do is, because I'm looking at 3, I'm going to write down all the 3 to the power of. So 3 to the power of 1 is 3, 3 squared is 9, and 3 cubed is 27. So once I do this, I can start kind of replacing 27 as 3 to the power of 3. And I've also got 9 here, which I can replace with 3 squared. So I'm simply going to rewrite this as 3 to the power of x multiplied. Instead of writing 27, I'm going to put down 3 to the power of 3. And then 9, I'm going to replace with 3 to the power of 2 and 2x. And so exactly what we did last time. Because in this case the 2 bases are the same, I'm going to add the powers. So that's going to be 3 to the power of x plus 3 equals, and then in this case, because it's powers of powers, I've got to multiply it. So I'm going to replace it with 3 to the power of 4x. Once I do this, because the 2 bases are the same, I can kind of get rid of it, and I've got left over is x plus 3 is equal to 4x, and then 3 is equal to 4x minus x. And if I'm to carry on, I'm going to get 3x equals to 3, and so x is equal to 3 divided by 3, so we can say x is equal to 1. Okay, so that is I think, you know, that could be that. I think that could be a merit question, because there is 2 steps involved in it. The achieve part is where you rewrite everything as base 3, and then it goes on to merit is when you actually try and solve the question. All right, let's go to question 2. So question 2 is a little bit extra in it, but it should be all right because it still follows the same rules of exponents. But as I said to you guys before, the reason I like doing exponent questions is because it actually covers a lot of linear algebra and quadratics as well. So it just kind of, that's why I really like starting with this, because it gives people a lot of confidence in terms of getting achieved just with rewriting numbers with the correct basis. So if we're having a look at this the second question here, straight away we can see that the base that we're looking at is 2. So on the side somewhere, 2 to the power 1, 2 squared is 4, then 8, 16, 32. Eventually we're going to get to 64, and that's actually 2 to the power of 6, because we got 3, 4, 5, 6, so on. So we're going to actually rewrite this now as 2 to the power of x squared minus x equals 2 to the power of 6. So once we do that, I think there's your achieve part kind of done already. I don't think you will get a question as like where you're just having like one number that you need to change. But because the two bases are the same, I'm going to cancel them out, and what I'm left over with is x squared minus x equals to 6. And what you're suddenly dealing with is you've actually got a quadratic equation that you're working with, because when you rearrange this, you're going to get x squared minus x minus 6 equals to 0. And because it's a quadratic, you're looking for two numbers that multiply to -6 and add up to -1. So we're going to get x minus 3 and x plus 2 equals to 0. And at this point, we can just say x minus 3 is equal to 0, or x plus 2 equals to 0. So rearranging this, we're going to get x is equal to 3, and then x is equal to -2. So those are our two answers for this particular question here. Okay, so what I'm going to do is I'm going to give you guys another question like this, very similar. So 2b, let me see if I can actually get it right. I know I've been having some difficulties with coming up with questions on the spot, but we're going to give it a go anyway. So we're going to go with 3x squared just thinking, is this going to work? Yeah, I think it'll work. Give it a go. So what I'd like you guys to do is have a go with this question and just try and figure out what x is. So I'm actually looking at this question here, but I'll leave the working up there for you guys so you can kind of see the idea behind it. I really hope it works out. -3 plus 3, yeah, it should work out, but let's see, unless I make a mistake. Hey Daniel, I will be doing some level 3 stuff later on. Not today, but sometime soon in the next couple of weeks. Looking at the questions, Aluna. These are some of the questions that you can potentially get in the MCAT, Aluna. So yeah, they end up being like merit or excellence questions, but you can still get achieved just by doing the first part of it. So that's what I'm trying to get you guys to see. I mean, once you get to the achieve part, it's actually pretty easy. It's just a matter of working through it. Ruma, I will have a look for some rearranging questions, because I think I saw some in the last year. There was a couple. So yeah, if we have some time towards the end, we'll actually do some. Okay. Anyway, let's go to question 2b. So as I said to you guys, we know what the base is. The lowest base in this case is 3. So I'm going to go with 3 to the power of 1 is 3. 3 squared is 9. 3 to the power of 3 is 27. So I'm going to rewrite 27, but leave the left-hand side as it is. So 27 is going to be written as 3 to the power of 3. And when I do that, my two 3's, they cancel out because they're the bases. So I'm going to rewrite this as x squared plus 2x is equal to 3. So I rearrange the quadratic, and I'm going to get x squared plus 2x minus 3 equals to 0. So factorizing this, I'm looking for two numbers that multiply to -3 and add to 2. And I've got that as my two factors. So then I can say x plus 3 equals to 0, or x minus 1 equals to 0. Therefore, x is equal to -3, or x is equal to +1. Dominic, simultaneous equations, I'm gonna have to look at some questions maybe the next time that I run this tutorial, because yeah, just want to get through these questions first, and then yeah, I'll definitely do some simultaneous equations, but it's just creating those questions can be a pain, and if I don't get the wording right, it ends up being a disaster like last year. So that's why I'm picking some easy ones to start off with today. All right, let's go to the next question. Now, this one that I have up here, question number 3, it ends up being, I think it is an excellence question, question number 3. So it's a little bit more work, but again, excuse me. Question number 3, it is an excellence question, but you can actually get up to merit with all the things that you've just learned so far today. All right, so that's why it's I would actually say just get into the habit of, with these exponential questions, just learn how far you can do this. Yes, I am a maths teacher, Riley. What else? Can you do the 2018 tables graphs paper? I'll probably do that either tomorrow or on Friday, but I've got to do a couple of complex level 3 papers as well. No, Annabelle, I just started doing these live streams literally today because I've been sick for a while, so I haven't actually had the chance to actually make any videos or even do live streams. But I will give you guys plenty of notice when I'm doing a live stream. The Leo and George with 27 students. I will have to find that question, Riley. Otherwise, what you can do is just put it on the comment section, the question, and then I'll keep it for next time. But anyway, look, let's go to question number 3 here. So again, the usual thing, replace all the numbers that are big numbers with the powers of 2. So I'm going to replace 4, because 4 could be written as 2 squared and 2 cubed is 8. Now this question, guys, easy merit to actually get up. All right, so all I can tell you is that I know it looks kind of crazy with that less than 8 symbol, but trust me, you can actually do this question. So what I'm going to do, I'm going to rewrite everything. So I've got 2 to the power of x squared multiplied by 4. I'm going to replace it with 2 squared, because remember that 2 squared equals to 4. So all I'm doing is just replacing 4 with 2 squared, and I've got x less than 8, which is actually 2/3 again. So I'm going to replace that with 2/3. Okay, so if you guys have a look at this question, pretty much the same rules apply. All right, exactly same rules. So it's going to be 2x squared times, you got the 2 powers that are getting multiplied, so it's going to be 2 to the power of 2x, and then that's less than 2 to the power of 3. In this case, I would actually say getting to this, probably this third line is going to get you to an achieved, I would say. Oh, that's a really nice question, Eliana. If I have some time, I'll get it done later. So then what we have is combining the 2 powers. So when we combine these 2 powers, we're going to actually add the powers. So it's going to be x squared plus 2x, and that's less than 2 to the power of 3. All right. At this point, you can kind of see that the 2 bases are the same. So cancel them out. And what you have left over is x squared plus 2x is less than 3. So, and at this point, what you can do is just rearrange it again. So you're going to get x squared plus 2x minus 3, because when I bring 3 over to the left-hand side, it becomes minus 3, and it's less than 0. All right. Even at this point, what you should be seeing is you're actually dealing with a quadratic. So what I generally tell people is this. From this step, it's a little bit of, what do you call it? A little bit extra work to do. But if you can actually do that little bit of extra work, then it's a guaranteed excellence that you're going to get if you ever see a question like this. And it was really weird because last year's in last year's exam paper, they had a question very similar to this one. So I think it's something useful to have in the kitty in terms of passing this whole MCAT, is like having like 1 or 2 questions which just seem to keep popping up, which end up being like a merit or excellence. So how do we do this question? The first step is this. Think about it like this. Just kind of go, I'm going to rewrite this as x squared plus 2x minus 3 equals to 0. And I'm actually going to work out what my 2 solutions are. Weirdly enough, the previous question was also the same thing. So we kind of already know that x plus 3, x minus 1 equals to 0. The reason I say this is because that's literally what we did in the previous question. So we've got our 2 answers. X is equal to minus 3 and positive 1. Now, here's how, I mean, if you actually do up to this part, you actually get a merit, okay? But if you want that excellence grade, there's that 1 extra bit that you need to do. And the reason you need to do this extra bit is because of this little symbol, which is less than 0, all right? So a couple of things that are quite useful to know is you're dealing with x squared. So x squared is actually a parabola. It's a graph that looks like this. So if it's positive x squared, it's going to look like this. And if it's minus x squared, it's going to look like this. So that means we're looking for when is this graph actually less than 0. So think about it like this. If this black line here represents 0, then we're trying to figure out when is it below 0. And we can kind of see that it's all of this part here that's actually below 0. But to get those 2 points where they cut are these 2 things that you actually solved. So that point ends up being minus 3. That point ends up being 1. So in other words, the final answer to this question, the way you write it is, you write it down like this: minus 3 less than x less than 1. All right. So again, going back to those 2 values that you calculated. So this point here becomes minus 3 and this point here becomes 1. So, and because we're actually looking for less than 0, we can't actually put this as less than or equal to. So that's why this ends up being less than. Okay. So that's why this particular question ends up being an excellence. It becomes an excellence just for writing this in the right format. Now, I have done some questions like this previously where you can actually go and have a look at it again. These are questions like, when is the parabola below the x-axis, or when is it always positive? Those kinds of questions. So for example, if they say, when is it below the x-axis, you're looking for less than 0. So that's below x-axis. Above x-axis, you're looking for greater than 0. They might say, when is the graph always positive? So if they say like, when is it always positive, you are looking at this symbol. Or when is it always negative, you're looking at less than 0. Okay. All right. Logs on questions we have to guess and check as a basis are in common factors. Okay, sorry, I'm just catching up on my messages here. As I said, Aliana, the little quadratic question that you have there, I will do that later on if I have some time. And also that linear question looks good as well. Scott, if you use logs on the questions where you guess and check at the basis are in common factors. Now, normally at level 1, they try not to give you guys with different bases. Bases are in common factors. I'm trying to understand what your question is. Okay, I'm going to come back to that, Scott. But Aliana, so there's 2 situations that can actually happen. This is the first situation, and I guess because we're actually talking about it, I'll show you guys what the other situation looks like. So the other situation is this. For example, if that same question that we had before, if it actually looked like this symbol, if it was greater than 0, then I'm still going to do all the same process. So I'm still going to factorize, and I'm going to get my 2 solutions, which ends up being -3 or 1. But when I actually go to draw it, okay, this is what my parabola would look like because it's a positive x squared. And then I've got my line there, which is 0. But this time I'm actually looking for greater than 0. And because I'm looking for greater than 0, I'm actually looking above the black line. So that's going to be this part here and this part here. And then if you look at the values, those values don't change. That's still going to be -3, and that is still going to be 1. But the only difference is, if the question was like this, where it says greater than 0, then the way you write it is you actually write it like this. X is to be less than -3, or X, this is the way you can write it. This is how I teach my guys to actually write it, so they actually remember. So basically, you've got two situations that could happen. So when it's less than 0, that's on the left-hand side. When it's greater than 0, that's on the right-hand side. So I guess your final answer could look like this if it's greater than 0, or it could actually look like this when it's less than 0. But again, it all depends on the parabola, because if the parabola is upside down, then it's going to work slightly different as well. But I always say this, take like a little highlighter, so you can kind of like draw a little graph and just sketch which zone you're looking for, and then you kind of just use that zone. And then even if you draw it, I think you can actually show the understanding, and if you make like minor mistakes, they might be okay with it, but don't quote me on that. But always it's a good idea to actually draw the little diagram and then get the two statements. Okay, so let's go to the next question, or should I actually give you guys a question like this, so for you guys to actually try it out? What are your thoughts? We got time. Because if there's nobody coming with what happens if the parabola is upside down? Okay, if the parabola is upside down, let's have a look. So let's say you get a question that looks like this. I'm trying to think of a question off the top of my head. So let's say we've got -x squared plus 2x. Wait. This is what happens when I try and do questions on the spot. Give me 1 second. I'm just going to open up my other window to try and get a question, something like that. So let's do -x squared plus 2x plus 3. Is that going to work? Oh yeah, that's going to work. Okay, so let's say we got this question here, -x squared plus 2x plus 3. I'm going back to Safari. Where's that? Yeah, will this end at 10 or what? What happens if the parabola is upside down? Yeah, I'll just show you guys how this question really works for the upside down one. So if it does look like this, where it's -x squared plus 2x plus 3, and we want to figure out when is it less than 0, the first thing we got to do is we got to try and factorize this. Okay, so I'm still going to follow the same rules for factorizing. So for factorizing, what I'm going to do is I'm going to put it like this. -x squared, I'm going to take negative out as a common factor. So that means this question ends up looking like this. All right, so then what happens is, because it's negative, I can rewrite this as now x squared minus 2x minus 3 is less than 0. And what you'll find is you can, how do I say it, this would still work. So even though you have an upside down graph, you can actually change it to a positive version of the graph by actually getting rid of that negative sign. So I hope that actually kind of answered your question there, whoever it was that asked. Yeah. Okay, so I hope that answered what happens when it goes upside down. I think it was Rumor that asked. So you can actually switch the signs. So when you switch the signs, but there is one thing, sorry, I forgot. Oh man, this is crucial. How could I forget this? The crucial part is this. Oh, that was a huge mistake. When you divide by a negative number on the opposite side, the sign always changes. Sorry about that. I knew something was not right when I actually did that question. So yeah, please remember that. Whenever you divide, whenever you're dealing with inequalities and you divide by a negative number, the sign actually changes. All right, I thought something was a bit weird about that little thing, but anyway, hopefully that helped, guys. Let's go to the couple of the other questions. So this question here, number 4, was actually sent to me by someone earlier today in one of the comments section. So I'm gonna try and see if I can move that, because I just need a bit more space. Got. Okay. All right, so for this question, and I've seen people do this so many times, where they actually try and think that they can actually write 50 as 3 to the power of something, and it's just so normal for people to actually do that straight away. But this question is slightly different. So have a look what happens here in this question. So again, the first rule, 27, I can replace 27 with 3 to the power of 3. Because remember that we always kind of start off with that. So 3 squared is 9, 3 to the power of 3 is 27. So I'm going to replace it with 3 to the power of 3. Now, unfortunately, I can't write 50 as 3 to the power of something, because 3 to the power of 4 equals 81. But I kid you not, I have seen students do this. They actually look at 50 and they just make this random as guess, and they write something like 3 to the power of 3.5 or something like that. All right, now one thing that I'll tell you guys, can you please post this live video to the live stream? I think this video gets automatically saved as a live stream, guys, so it just pops up somewhere, but I will actually make it public so you guys can actually kind of watch it again. But yeah, please don't do this. Please don't write 3 to the power of 3.5 and things like that, because I'll tell you this right now, in level 1 MCAT, you're not allowed to use a calculator, right? Because you're not allowed to use a calculator, you will never get 3 to the power, like I'm talking about the powers here. Your powers should not be a decimal. They'll majority of the time should be a whole number. It won't be like a 3.15 or something like that. Is it x is greater than 7.5? Is it for this answer? Well, I don't know. We're about to find out. All right, let's have a look. So 50 just is going to stay as is. I'm not going to do anything to 50. So here, because the I'm talking about, you can't actually see my mouse. Okay, so I'm actually looking at here, because the two bases are the same. I can rewrite this as 3 to the power of x plus 5 minus 3, because remember, when you divide with the same basis, you subtract the powers, and then that's greater than 50. So at this point, I can rewrite this as 3 to the power of x plus 5 minus 3 is 2, greater than 50. What we got? Okay, sweet. So now I just got to try and figure out what's like the number x could actually have, so that this number will be bigger than 50. So I guess what I have to do is and that's one of the main reasons why I actually have this little table here. So I'm actually looking for an answer for x such that this is going to be true. So for example, if I put x equals to 1, and guys, you are allowed to do this in the assessment. So you can actually just go, if x equals to 1, then this would be 3 to the power of 1 plus 2, which is greater than 50, which is 3 to the power of 3, which is greater than 50. 27 is greater than 50. Well, no, so that's not going to work. So then we go into our next number. So x is equal to 2. Then we're going to get 3 to the power of 2 plus 2 is greater than 50. Then we're going to get 3 to the power of 4, which is greater than 50. 3 to the power of 4 is 81. 81 is greater than 50. So that's a tick. But here's the thing though. You also get, if you go to x equals to 3, then that number is going to be 3 to the power of 3 plus 2, greater than 50. 3 to the power of 5 is greater than 50. Well, we know 3 to the power of 4 is already 81. So the next number is going to be bigger than 81. That means this is going to work out as well. So from here, you can actually have two answers. Your first answer you can say is that x has to be greater than 1. Or your other answer could be x is greater than or equal to 2. So yeah, so those are the two answers. You can actually have either one of those answers, and you can also do this entire working on the side there if you're unsure of how to actually answer this question, and potentially that gets a I think these are excellence questions that I remember seeing them as. Annabelle, yeah, you can actually guess and check, because let me just have a quick look at the schedule from last year for this particular question. 91027 schedule. Because with guess and check, where is it? My guidelines. Where was this question? I remember seeing this somewhere. Give me a second, guys. Just looking for this question. Question 1B, guess and check. Guess and check following at least one correct algebraic process leading to correct answers can be awarded a T grade. Okay, so to answer your question, who was it asked? Annabelle, you asked that question, will you get excellence if you still do guess and check? According to the marking schedule here, it actually says guess and check following at least one correct algebraic process. So I would actually say, if you can actually get up to, so this is an algebraic process there, this is another process there. So I think if you show one of those processes, you could potentially get an excellence for it. Because I'll be honest, like, you know, even though, like, you know, I do these types of questions, when I get to this stage, I still kind of use this kind of method just to kind of see what the answer is. This is what I would do it. I'm not trying to say that I can just look at it and go, I can solve it. It doesn't work like that. So this is the way I do it, and that is absolutely fine. You asked, how did you get x greater than 1? Selena, well, that's because I'm looking for a number that's actually bigger than 1, a whole number that's actually bigger than 1. So that means it's got to be, when I say bigger than 1, that means you got 2, 3, 4, and so on. So that's why there's actually two answers for this question. You could actually say that either x is greater than 1, or you can say x is greater than or equal to 2. So it's just another way of saying it. Okay, so in saying that, let me just go back and see. I think I saw a very interesting question that might 25 minus 3 or equal to, no, that's the other question I had a look at. Okay, so I'm just going to get rid of one of these questions that was actually asked earlier, which was a linear inequation question, which kind of covers a couple of things, which covers rearranging as well as inequalities. So just going to copy the question down first. Where did it go? We got 25 minus 3x. That's a good question, by the way. So this was one of the inequality questions. 25 minus 3x is less than or equal to 12. All right, sweet. Do you have to put the two answers to get an excellence? No, you don't. Just one is perfectly fine, Hannah. Okay, so anyway, this is one of these questions that actually popped up, and I know some people ask for rearranging questions, but also this is a nice inequality question to kind of get the ideas. So rearranging is, you know, they follow the same rules as with the inequalities. They follow the same rules. So I want to have x here by itself. So when I rearrange this, I'm going to get 12 take away 25, because 25 is positive. Switching over to the other side is going to make it a minus. So I've got negative 3x is less than or equal to minus 13. And again, remember I told you guys this, which I made that mistake earlier, is when you divide by a negative number with inequalities, you've actually got to change the symbol. So this will become negative 13 divided by negative 3, but of course the symbol is going to change and it's going to look like this. So your final answer when simplified with those two negatives that go away, you can just rewrite this as x is greater than or equal to 13. Do you need to factorize it first? Chinmay, which question are you talking about? Do you need to factorize it first? All right, not sure if Chinmay got my message, but it's all right. There was another quadratic question here which looked quite horrible, to be honest, but it's I'm gonna try and do that because I think this question is actually an excellence question. I would probably say no, maybe a merit, I don't know, but it's just these guys, they keep changing what do you call it, all the requirements. So I'm just gonna copy this question down, guys, and I'm gonna try and do this. So this was another question from the tutorial, which is, we had a question earlier about simplifying. So we had a simplifying question, which was 3x squared. Oh, that is a horrible question, I'm not gonna lie. Over 2x squared plus 3x plus 20. I think it was Aliana, you asked me this question. I'm just gonna check something first because that number looks a bit weird. 13x minus 36. Yeah, I'm thinking that you've actually given me the wrong question there, Aliana, because that number does not, I'm looking at the top quadratic, is not going to make sense. What year was that? Let's have a look. How do you know when to switch the symbols? Okay, Lewin, whenever you divide by a negative number, so I'm actually looking at here. Whenever you divide a equation by a negative number, that's when you actually change the symbols. That's the only time you change the symbols. Otherwise, you treat it exactly the same way as it is. And I'll tell you guys this, all right? Most of the MCAT questions, when they have linear inequations, majority of the time I've actually seen it where they will have a negative number where you have to divide by a negative number, so therefore the sign will switch, but just keep an eye on that. What year was the hard MCAT? That was, yeah, it was a bit of a story, but let's see what else. I thought you would need to factorize the inequalities, but I was doing something wrong. No, you don't need to factorize that. Are there ever simultaneous equations that contain inequalities? Daniel, unfortunately, yes, there are simultaneous equations that I've seen that have inequalities. I think it was in 2017 or even 2016. If you have a look at the papers there that I've done, the exam papers that I've done, have a look at it, and yeah, there's some couple of inequalities. Selena, how did negative 13 over negative 3 turn into positive? Well, when you divide two negative numbers, you get a positive number. I think I've already answered that. Two negatives cancel out. I heard it earlier from Marx. Yeah. I also tried the quadratic dividing question, wasn't able to factorizing it. Yeah, because just going back to that quadratic question that was posted earlier, I think that number is not 13x, but I think if it was 12x, I think it might work out, but let me just 3x is supposed to be with 36 and the 13x is with 20. Let me just have a look at that and see if they factorize first before getting on, because I don't want to, definitely don't want to be doing. Okay, so that's one of them. All right, and then the next one is 2x squared. I'm particularly worried about the 2x squared plus 3x plus 20, because I think, yeah, I'm right, that's not gonna factorize unless it was a minus 3x. Let me see if that works out. No, that doesn't work out as well. Okay, so what I might do is, this is quadratic question, I might just do a slightly different version so you guys can actually see what it looks like. X minus 2x plus 5. Okay, so I'm going to change that to something else so you guys can actually see how that works. So let's go 2x squared. What do we got? 2x squared plus 8. Let's try plus 8. No? Yeah, let's try plus 8. Okay. Just because I'm just making up this question on the spot here, we're going to go with this question. Could you try please work out? Okay. What the word equations? I get substantially low. Hannah, I probably will be going through the word equations with the simultaneous equations later on. There are some tactics that you can actually do to how to get rid of them. But look, I've got 2 more of these questions that I want to get rid of. So get rid of this question here first. Sorry, that wasn't a plus 8. That should have been a minus 8. See, this is what happens when I try to make questions on the spot. Okay, so the top line, if you have a look at the top line, they all have a common factor of 3. And I think it's something that's very useful to know is that when you see like they say a question like where they say simplify a quadratic equation where it's like you got 2 quadratics, one on the numerator and one on the denominator, what you got to do is you got to factorize them. All right. In this case, I've actually purposely made this question fairly easy because I'm just mindful of time. But I can rewrite this as 3x squared plus 4x minus 6. So I've taken 3 out as a common factor. That's not going to be 6, that's going to be 12. All right, and in the denominator, I've got 2 as a common factor. I can take it out, and that's going to be x squared minus 4. All right, so what you then do at this point is you can factorize the numerator because you're looking for 2 numbers that multiply to negative 12 and add to 4. So that's going to be x plus 6, x minus 2. And then in the denominator, you're looking for 2 numbers that multiply to negative 4 and add up to 0. And of course, that's difference of 2 squares, so we can just write that as x minus 2, x plus 2. And at this point, you're going to get like 2 of these brackets that cancel out. And what you end up with is 3x plus 6 over 2x plus 2. Unfortunately, you can't actually do any more in this. So yeah, that's where it actually stops. Jonathan, I see that you've actually got a question. What I would say, Jonathan, is see if we can just can you guys actually write any comments in the stream? Don't know. I don't think you can by the looks of it. Okay, what I would say, Jonathan, is for the next session I might actually set up a space where you guys can actually put up some questions, and then I'll just grab questions from there and then just answer it in the next tutorial. That's the best way to go about this. Yeah, I've got 2 more questions that I got to work on, man, and then I'm going to do simultaneous equations next time, the next session that I do. So these are the last 2 questions I actually want to do. Just mindful of time at the moment. And the reason I actually want to focus on these 2 questions again is because I've actually seen them pop up in the last 2 years worth of exams. They just seem to keep coming back again and again. So I've kind of made a simplified version of it. This is question 5 I'm looking at. And then I'll actually show you guys how to do it. So the way to kind of do it is that you got to try and work out the perimeter first. So to work out the perimeter, we know we've got to actually look at all of these sides. So we've basically got to go that, and that, add it all up. That's your perimeter. The problem though is that some of the sides are actually missing. So the way to work it is I actually go, okay, so this part here is worth x, this part here is worth 4. And that means that the 2 yellow parts at the bottom is going to match the top yellow part. So I can rewrite the top line as x plus 4. The next thing is I can actually say the pink part here and the pink part here should be the same as the pink part here. So which means I'm looking at this one, it's going to be 3x because that's the long length minus x plus 1. But here's where I see people make a mistake, is they actually forget, they just write it like this, they write x plus 1. But in reality, there's a little bracket around x plus 1. Okay, so, and I think if you get that, then things actually become a little bit easier, because now when we actually solve this, we're going to get 3x minus x minus 1. 3x minus x is 2x. And so what this side ends up being is 2x minus 1. So what I'm going to do is I'm going to start at this point here, and I'm going to go clockwise, and I'm going to write down everything. All right, so when I start from that green X mark, so this is part A, I've got 3x first, plus x plus 4, plus x plus 1, plus 4, plus 2x minus 1, and then plus x. So simplifying all of this, what I've got is 3x, 4x, 5x, 6x, and I've got 8 x's. And as for the number, what I also have is 4, 5, 9. 9 and minus 1, 8. Sorry, just kind of looking at something else and I got distracted. Plus 8, that's the perimeter. Okay, so one more little trick that's kind of handy is for the perimeter, particularly with this type of shape, what you can do is actually just take this length here and this length here. So that's 3x plus x plus 4, and then multiply it by 2. Because literally that's what's happening. So you don't even have to actually do all of this step. You can just look at the two borders outside, and I'm talking about the 3x. Because remember, that green line is the same thing as saying that pink line here. So you've actually got two lots of that. So what you could also do is, instead of doing this, you just go 3x plus x plus 4 and then multiply it by 2, because you got two lots of them. So this will be 4x plus 4 times 2, which means you end up getting 8x plus 8, which is the same answer as what you got here before. When formatting, sorry, I'm just looking at the comments here. I think the brackets is just for the x plus 1 that I'd be worried about, because there's a minus in front of x plus 1, but the rest of it you don't actually need any kind of brackets at all. You can just do as is. So will I be wrong if you don't use brackets? No, Ruma, you won't be wrong, but I think the only part you need to use brackets is this bit right here. Because of this minus here in front of that bracket, it actually it changes that plus 1 to a minus 1. So that's the only thing you need to remember. That's the only time you need to use that bracket for it. Otherwise, the rest of the time you can just do it without it. Okay, so the next part is, it says find x if the area is 24. So I'm just going to kind of go take this diagram again. So I've got 3x, x plus 4. Sorry, I just need to kind of do that diagram again. So what I had was, I had 3x, x, 4, and x plus 1. And then the area was equal to 24 for this shape, and I needed to find out what x was. So what I'm going to do is I'm going to split them up into two rectangles. All right. So my first rectangle, so this is rectangle 1 and rectangle 2. So rectangle 1, I've got base times height, plus rectangle 2, base times height, equals total area is 24. So looking at this, and again guys, for this type of question, even if you don't know how to get to the final answer, just setting up the equation can get you an achieved as well. So always remember, in MCAT, don't leave anything empty. Just attempt as much as you can, because you do end up getting grades for, like, you know, setting up the equations. So in this case, I look at my first, so I'm looking at my first rectangle, and I've got my base, which is x, and then my height is 3x. So I'm going to have x times 3x plus my second rectangle here. I've got the base here as 4 and the height as x plus 1. So I got 4 times x plus 1. But of course, remember, this time you need that x plus 1 as a bracket. And this is equal to 24. So expanding this, we got 3x times x, which is 3x squared, plus 4 times x, and then 4 times 1, which is going to be just 4, equals 24. So rearranging this, we're going to get 3x squared plus 4x plus 4 minus 24, and that is equal to 0. So we got 3x squared plus 4x minus 20 equals to 0. What have I got this? So yeah, so basically at this point I just need to factorize it, guys. So I'm looking, and look, I'll be honest, when it comes to quadratic factorizing with these kind of things, just to show you guys, I think getting setting up the question and getting to a quadratic like this could result in either achieved or a merit, depending on what the question is. But I would probably say, I think getting up to here, you're probably looking at, man, I'm really hard to say. I'd probably say merit. But anyway, so I'm going to kind of quickly do this because I realize I'm running over time. So I've got 3 times negative 20, which is negative 60. So I'm looking for two numbers that multiply to negative 60 and add up to positive 4. So that's going to be 10 and negative 6. So what I'm going to do is I'm going to write this as 3x squared minus 6x plus 10x minus 20 equals to 0. And then I got to split them up into 2 areas. Sorry guys, I'm going through this really fast, but I'm very mindful of time at the moment. So factorizing this, I've got 3x, I've got x minus 2, and then on this side I've got 10 as a common factor, which is x minus 2 equals to 0. So then I can say 3x plus 10 times x minus 2 equals to 0. What I've got is I've got 2 answers. So I've got 3x plus 10 equals to 0, or x minus 2 equals to 0. So rearranging this, x is equal to positive 2, and on this side I'm going to get 3x is negative 10, and then x is negative 10 over 3. Now remember, we are actually working with an area, so therefore definitely x can't be negative, so x has to be 2. And to get excellence in this question, I would actually say to you guys that you need to actually say that x can't be negative and x can only be 2. All right. I do apologize for rushing through that question. If you do want to try another question like this, what I might actually do is, I can't believe I'm actually going to do this, but homework? No homework. There is another question here, question number 6. If you guys want to actually have a go by yourself to try and do this, I might just kind of start the next tutorial with this question, because I realize I'm running out of time. Unless people want to hang around and let me actually finish this question. Just let me know if you want me to finish this question. Does he have a website? No, Hannah, I just have all my videos are actually up on the YouTube channel. So finish it is. All right, so Jonathan, before you could go, tell us when your next tutorial is. Look, mate, I'll be brutally honest, like I would love to do this every night and then, but yeah, I got a toddler that I gotta look after. So at the moment, Tuesday, what do we got on Thursday? I just need to check my planner, guys. And then, please finish finish as in finish the question. Okay, right. Okay, yeah, okay, I'll finish the question. Yeah, look, I will just put it up on the community, I'll just put up on the community thing when I'm actually doing my next tutorial. But yeah, I will finish this question first, so kind of get this out of the way. Okay, so what we've got in this particular question is we've actually got we got to split this question up into a rectangle and a triangle. All right, so I'm going to kind of split that up as a rectangle and a triangle. When I do that, I think what you guys need to realize is that on the left hand side, because this side here is x, this is also going to be x. So I'm going to replace that with x, which means the top part is going to be 3. So to kind of make sense, that x plus 3 is the whole length there. That's what x plus 3 is. It's the whole length from there to there. But because we've split it up now, we've got x at the bottom half and then 3 at the top. So what we have is we've got two zones once again. We've got zone 1, which is a triangle, zone 2, which is a rectangle. Now, just to kind of throw you off a little bit, you can actually use a trapezium formula if you're comfortable with trapezium. If you want to try that, a trapezium's area is, you've got half times a plus b times height. That's one way of doing it, where you're going to end up with an equation like this, where 30 is the area, half, and then a and b are the two parallel sides. So in this case, it's going to be x plus 3 plus x, and then the height is going to be x minus 2. So that's one way of doing this equation. But the other way of doing this is I'm going to do it as a triangle and a rectangle. So I've got triangle 1 and then rectangle 2. So add them up and I get 30. So for triangle, I've got half times base times height plus rectangle, which is base times height. So if I look at this, for the triangle, this, wrong color. I don't like that color. Let's get rid of that. What haven't I used? So this is x minus 2, which means for the base of the triangle, it's also going to be the same as the base of the rectangle. So base of the triangle is going to be x minus 2. So I got half multiplied by x minus 2. And for the triangle, the height is actually 3, which is kind of shown right there. So that's multiplied by 3, plus the base of the rectangle is x minus 2, and then height for the rectangle is just x. So just to kind of point it out, so that's my height right there, and then the base is x minus 2 there. Okay, and all of this is equal to 30. So now I need to actually figure out how to actually put this together. So what I've got is a half times 3 times x is 3x, 3 times minus 2 is negative 6, plus x times x is x squared, and then minus 2 times x is minus 2x equals to 30. All right, so the next step is I need to get rid of this half. So I'm actually gonna do, I'm just trying to think what's the easier way of getting rid of this half. I just have to expand it. There's no other way of doing this. So half times 3 is 3 over 2x, and then half times minus 6 is negative 3, plus x squared minus 2x equals 30. Now you're thinking, oh man, there's this 3 over 2x. You know, I'm not going to lie, it is bloody horrible. If you want to change it to 1.5x, you can, because 3 over 2 is 1.5. But don't panic. I will actually show you guys how to actually kind of manipulate that as well. So first things first, let's bring this 30 over to this side and simplify things. So I'm going to write down x squared. That's first. Then I've got negative 2x plus 1.5x, which is equal to 0.5x. Minus 3, I'm going to leave it as it is. And then I've got 30, which comes over to the left-hand side. So it becomes minus 30, and that equals to 0. And so what ends up happening is I've got x squared plus 0.5x minus 33 equals to 0. Why is that happening? Now, you're thinking, yeah, it's all great, but I've got negative 33 and I've got 0.5. What you don't want to be doing is you don't want to be dealing with 0.5x's, okay? So if you want to get rid of 0.5x, what you got to do is you got to times the entire equation, everything by 2, all right? So what I'm going to do is I'm actually going to do this everything by 2. So that means I'm actually going to get 2 times x squared, 2 times 0.5x, 2 times negative 33, and 2 times 0. So when I do that, it ends up looking like this. So I've got 2x squared plus 0.5x times 2 is 1x. And then negative 33 times 2 is negative 66, which equals to 0. I'm really getting annoyed by that bar downstairs, but that's all right. So once I get this, then I can actually kind of do that quadratic manipulation again. So I've got 2 times negative 66, which is negative 132. So I'm looking for two numbers that multiply to negative 132 and add up to plus 1. And I guess this is where being good with your times table helps, because it's when you have 12 times 11, 12 and 11 kind of works out, but it's going to be minus. So 12 times negative 11 is negative 132, and 12 plus negative 11 is 1. So I can rewrite this as 2x squared. Give me 1 second, guys. I'm just going to get rid of this bloody keyboard. Let's see if that helps, because that stupid thing just keeps annoying me. Oh, man. Just keeps coming back. Okay, so we've got... Okay, this is just stupid. Let's try this. So 2x squared, and then I've got plus 12x. Get rid of all this tech. We've got minus 11x minus 66 equals to 0. Now you might be wondering, how the hell did I actually know it was 12 times 11? I'll give you guys a bit of a kind of a hint. Like this number 66, when I had a look at 66, I kind of knew it had something to do with 11, and that's how I kind of had this kind of guessing check that I knew it was going to end up looking like 11 anyway. So once we get this, we're going to split them up into two areas. So we've got 2x and then x plus 6. We got minus 11 as a common factor, and that's also x plus 6 equals to 0. So you end up getting 2x minus 11 multiplied by x plus 6 equals to 0. Have I done this right? Because something doesn't feel right here. Because I know when I made this question I did do a nice number, but this is not looking right. Where have I made a mistake? Have I made a mistake somewhere here? Minus 33, this all looks right. That's fine, let's keep going. So I've got 2x minus 11 equals to 0, or x plus 6 equals to 0. Everything looks right so far. I was supposed to get 6 as my answer. It's negative 0.5, negative 0.5. Where's my mistake? Thank you, someone actually picked it up. Yes, you're right. Thank you so much. I appreciate that. There's a negative 0.5. Negative 2 and 1.5 should be negative 0.5. Thank you, guys. So that's going to be a negative, which means that's going to be negative 1x. Oh, man. If that's negative 1x, then my whole... Ah, lovely. This whole thing is just screwed up. Yep. One little mistake and... Well, that's something to learn. See how like one bloody symbol can end up screwing up your whole question. Perfect time to do it, right at the end of the tutorial. Okay, anyway, so this was negative 1. So let's see. 2 times negative 66, that's still going to be negative 132. But I'm looking for negative 1, which means the two numbers are going to be negative 12 and positive 11, because I thought something was not right with that. Okay, so then we can redo this whole thing again. 2x squared minus 12x plus 11x minus 66 equals to 0. Ooh, is there still a screeching noise? How about now? I haven't actually moved anything. I'm just trying to see if there's a high-pitched noise coming. Let me hear it. Oh wow, okay. I'm going to finish this question off, guys, real quickly, and then I've got to do try and figure out what the hell is actually happening with my systems here. Anyway, so what we have is we've got 2x as a common factor, so we can take out x minus 6, and then 11 as a common factor, x minus 6 equals to 0. So what we end up getting is 2x plus 7 times x minus 6 equals to 0. It's getting louder. Wow. Okay, I will finish off this question, and I will have to try and figure out what the hell is actually happening with the noise. So, kind of finishing off quickly, guys, here. Ooh, that is screechy. So 2x plus 11 equals 0, or x minus 6 equals 0. So x is equal to negative 11. And then x is equal to negative 11 over 2. Or in this side, we've got x equals to positive 6. So if you go back to the question, one of this side here was a positive x, was one of the sides. So that means you can't actually have a negative value for x, and x has to equal to 6. Yeah, so the noise, it's really weird because I just moved my tablet from my table and it seems like it's gone now, so it's crazy. So a lot of things to learn. All right, so guys, so with this question, x should equal to finally to 6. And again, a good way to check is go back and put it back into the equation and see if it actually works out. But yeah, that's basically it. Okay, so I know we went kind of over 17 minutes over the time. I do apologize. So as I said to you guys before, I will try and figure out when my next one is depending on my time. Did you note, Fabian? No, you can actually use the trapezium formula also, Fabian, to work out this question. It's just another way of doing it, that's all. So you don't need to like remember. I mean, if you know it, it's useful. But if you don't know it, you can always split it up as a triangle and a rectangle to try and do this question. All right. That's basically it from me, guys. So if you have any questions, I'll hang around for the next 4 or 5 minutes before heading out. But what I will do is I will keep an eye out on the community notice. I'll probably try and do another one. Definitely try and do another one. I don't know if I can do it this week, but maybe I'll just set up a poll just to see which day is good. But I definitely will be doing at least 2 or 3 before the MCAT. And as always, if you guys need more MCAT videos, I think if you go to my channel, particularly under playlist, there is heaps and heaps of questions, MCAT prep questions. So if you go to playlist, I'm kind of trying to show it to you guys here at the same time as doing this. Just in my playlist, NCEA level 1. So you got this 2018 prep questions. They're really good for revision. So you can actually do like one question at a time. And then you've got the 2017 MCAT prep questions, which are really useful as well. And also the other thing that's even more useful is particularly this playlist right here, which is all the exam papers that I've done from 2015 onwards, I think. Banana carrot, that's a lot of work to try and create a question paper, because I don't actually teach this standard to my students, because in our school we don't actually do the MCAT. So I'm just doing this to help out people, that's it. So it's kind of like I'd be killing a lot of time creating that paper. So majority of the questions that I've actually created on my own is actually in the 2018 playlist. Zayden, to answer your question, I think it's just annoying, some of the questions that they actually ask. But I actually say this to people, it's actually easier to pass level 2 maths than MCAT sometimes, because MCAT is just like, sometimes they just have these really annoying questions. But level 2 algebra is way more straightforward than level 1. Yeah, so NZQA has a lot of old papers there that are worth, but just bear in mind that some of the old papers, like particularly if you go beyond 2014, it's really weird, because like in 2014, an excellence question, the same question that's been asked in like 2018 is worth like a merit. It does kind of change, and 2014 and 13 papers were a lot more simpler. Has the tables equations paper changed? A little bits, I think, from last year. I think there was a bit of change. So I will be doing the 2018 paper sometime in the next couple of, probably next week sometime. Just trying to see when I get some time to do it. So yeah, I will do that paper, so you guys can actually have a look through that as well. Sound is all good. What else do we have? Jonathan, yes, I've got to do the geometric reasoning. I missed it last year. I just literally ran out of time to actually get them all out. But the geometric reasoning paper, I will probably do that. I'll do the tables equations first, and then I've got to do some level 3 exam papers for some of the level 3 students. And then after that, I'll be doing a geometric reasoning. So probably not sometime in like, maybe not next week, but the week after that maybe. Tables, equations, and graph papers. It's an odd paper, Lewin, because you know that entire paper you can actually do it by algebra. You don't even need to do a single graph to actually pass that paper. You can actually do all by algebra. So if you're good with algebra, then you'll be pretty sweet. I struggled with the word answers. Yeah, Dominic, I can't forget about the calculus papers, because there are some year 13 students that have actually been kind of following my tutorials since they were level 1, so I kind of feel bad kind of forgetting about those guys. But yeah, so next, what I'll do, Jonathan, is like I'll set up a link where you guys can actually post some questions for simultaneous equations. Alyana, no worries, man. Like it's I do get something out of it. The fact that I'm actually helping some people out, it's all good. So don't worry about it, because I do get something out of this. I just get satisfaction that people are going okay with it. So Zayden, there is a link on my. There's heaps of play. I'll see if I can post the link up for my past exam papers, mate. Give me a second, because you can just access all my old exams that I've done. Where is it? Live stream. Yeah. It's possible to check. So that's the playlist you want to be having a look at, Zayden. That's all got all the old MCAT papers. Jonathan, yes, I'll be uploading this live stream, but I might actually put it on see if I can create like a playlist or something like that. Hannah, one thing that I'll say to you is tables and graphs is just annoying. It's not hard, it's just annoying. They just have these really weird expectations. LlamaCon, I kind of stay away from stats. The reason I stay away from stats is I've got a really good friend of mine that she does all the stats videos, and she is pretty phenomenal. I'll see if I can find her YouTube channel, and I'll pass it on to you. So anything stats related, level 1, 2, 3. Let's see, where's my thing? Put it up here. There we go. This channel here will have all of your stats, whatever you need. Oh, noise is back. Sorry, I put my tablet down. Stupid thing. Sorry. Yeah. So if you guys have a look at her YouTube channel, she has all the stat stuff for level 1, 2, and 3, and she's pretty amazing in terms of explaining stat stuff. And yeah, she does have chance and data paper, Selena, and level 2 probability, Llama. Yeah, I'm with you, Banana Carrot, on that one, because I'll be honest, mate. Like I look at the tables and graphs paper, and sometimes I go, I've got no clue what it is that they're trying to ask, even though I know how to do majority of the things. But that's always been the problem. I'm trying to move my mic. I think I need a new tablet. Is the noise still there? Yeah, I'll have a play around with my tablet just to try and fix things. But anyway, guys, I will leave that at this moment. I'll take calculus for next year then, cause I have you for help. Yeah, Zayden, all my work is here. I've still yet to make calculus videos, which I am supposed to do. But thank you guys for joining, and it was nice small group to work with to kind of help out. And yeah, I'll post a link soon on when the next one will be. So okay, yeah, I'm actually holding my tablet. That's why it's not on the ground. So might see if I can get a mic for this. But anyway, I'll leave you guys to it. Thank you guys, and I will put the next message up and see you guys next time. All right. And if you do have any prelims before that, good luck for it. Make sure you answer every single question. What was the link? Selena, what's the link for stats is up the top there. There's 2 links that I've posted. Let me just post it again. Fabian, I teach at Ormiston Senior College. It's in Auckland. Sweet. I'm gonna catch up with you guys later. All right. Good night, everyone. Yeah, try and figure out how the hell do I stop this stream. There we go. All right. We'll post the link later. See you, folks. Thank you for joining.